Hi, in this really short video, I'm going to just preview today's assignment. For this assignment, it is really nothing new, just a factoring practice. So you have 15 assignments, or 15 questions rather. I've got two that I'm going to do with you. Um, through 1 through 4 are kind of new, but 5 through 15 are just the same things you've been doing since we started the factoring unit. So for multi-step factoring problems, so I'm going to click on problem number 1, and please write this down in your notes. And this can just go in your work. You are not submitting a copy of notes today because all you're doing is practicing. So I just need you to write this down, and I will go ahead and work it out with you. And I'm also going to work out 3. So I'm gonna do number 1 for you. Number 2 looks like number 1. Then I'm gonna do number 3 for you, and number 4 looks like number 3. And that's it. Okay, so short video today. So number 1, we have to factor 3x squared plus 42x plus 39. Now, what you learned yesterday is that if your a value is greater than 1, you've got to list those factors of 3. But what I want you to look at is that these are 3 kind of, at least 42 and 39, those are kind of bigger numbers. But I also look at this and say, 3 goes into 39 13 times. How do I know that? Because 3 is divisible by 3 and 9 is divisible by 3. So I just want to check real quick to see if we might have a GCF here. And so I'm going to use my calculator on my phone and just do, well, 39, we know that's divisible by 3. Is 42 divisible by 3? And I get an integer, which means it is a whole number, okay? So that means I have a GCF of 3, and I'm going to divide every term by that GCF first to simplify it. So again, remember that anything divided by itself equals 1. So this is an understood 1x squared. 42 divided by 3 was 14, so that's going to be plus 14x. And then plus 39 divided by 3, again, was 13. So I factored out a GCF, but what we notice is that these trinomials here, these quadratic trinomials, we've been factoring these. In fact, here my a value equals 1. So if you need to refer back to your a equals 1 lesson, then we're going to continue to factor this. But what we have to remember is to continue to bring down our 3. And recall that we factor trinomials first by looking at their signs. If my constant's positive, then I look to the sign of my linear term and copy that. My x squared breaks down into x and x. And 13 is a prime number. The only factors of 13 are 13 and 1, so therefore we're going to use 13 and 1 to make 14, and that makes sense because 13x plus 1x give us 14x, so it checks out. And of course, we can type this in y1 and y2 like I've taught you before. So this is how you would do number 1, and therefore number 2 also. You need to look for that GCF. So if I go back to this assignment, of course, we can just type it in here. If I look at number 2, just to preview, you can see, oh, they're all multiples of 5. So pay attention. So when you divide out that 5, keep in mind that a negative divided by a positive 5 is going to be a negative. So in your trinomial factor, you should have these minus signs as well. So your job is to go ahead and continue to factor that. So I'm going to preview number 3 for you. So write this down. It's okay if you're out of order. You can do 1, 3, and then 2, 4 in your note. In your work, you are going to submit a picture of your work. So I'm going to flip back here now to my ladybug. And it was, ooh, did I pay attention? It was 81 minus x to the 8th. 81 minus x to the 8th. So when I look at this, I think, oh, that's like this lesson from yesterday. This is a difference, meaning we're subtracting, of 2 perfect squares, or difference of squares for short. So you can look at your notes from yesterday for help on this. Was it x to the 4th, rather? I wrote it wrong, didn't I? It was x to the 8th. What am I thinking? So let me go back here and change that to an 8. That's really important because this is different for a reason. We know that 81 is a perfect square. The square root is 9. We've got a minus, and our exponent is even. Remember, that was one of the criteria from the lesson, was that our exponent was even, and then all we did was split it in half. So we know that a difference of squares factors into two binomials, one being a sum and one being a difference. And I do encourage you to put plus then minus, because you're going to see in a minute we're going to continue to expand this out. So when we fill this in, the square root of 81 is 9. And then x to the 8th, remember we just split it up into x to the 4th. So that's factored correctly. It's just not factored completely. And the reason why is one of our factors is another difference of squares. So this can be broken down. So when we continue to factor something, we can't leave something off, right? So we got to continue to bring that factor down. Now this here will factor into two binomial factors itself, one being a sum and one being a difference. And then I'm just going to take the square root of 9, which is 3, and the square root of x to the 4th, which is x squared. Now, there are problems where, by the way, if you break it down and get a perfect square, potentially you could break it down and get another perfect square, but 3 is not a perfect square. We cannot take the square root of 3 and get an integer, so we are through at this point. These are not factorable. These are sums of squares, and sums of squares are prime. A difference of squares can be factored. This is not a difference of squares because 3 is not a perfect square. And that's how you would enter that in, okay? Technically, the order would not matter, but I like to put plus minus. That way, if there is another difference, we can continue to break that down. And we're through. And again, yes, you can check this in Y1 and Y2 and verify your answer before submitting it. And then lastly, for number 4, I'm not going to work it out for you, but this is the one for you to practice. So you are going to break that down. Notice the 81 is still the same number. You're just going to do likewise. And as long as when we break this 81 down, we get another perfect square, and our exponent, when we break it down, is even, then we can factor the one that is a difference of squares. Hope that helps. So work that out. You are able to go to watch video, and on yours you should have a show examples if you need help. All right, good luck.